Gemma 2 Coder is an attempt to solve the reasoning gap in small language models, utilizing a two-phase fine-tuning approach centered around coding. Testing shows an improvement to 85% reasoning quality over the base model's 47%. The recipe for the model combines supervised fine-tuning for general structure with GRPO for rewarding correct coding, and was adapted from the method used to train DeepSeek. In Phase 1, we used a diverse dataset, mixing math science and coding to teach format without erasing the base model's knowledge. In Phase 2, we shifted to high-intensity specialization. We flooded the model with leak code and debugging examples. To enforce reliability, we designed a custom gauntlet of 4 reward functions. We moved beyond simple correctness. The model is rewarded for valid XML structure and passing Python syntax checks. We implemented a nuclear penalty for hallucinations and a reward for variable tracing. The training data was pre-engineered to trigger these rewards. Now we go to some examples of the improved reasoning. In this comparison, we test basic state tracking. The base model shown on the left tries to solve the tank problem. It attempts a single-pass calculation and confidently hallucinates 130 liters. That is incorrect. Now look at the fine-tuned model. It triggers the reasoning tag, pauses to calculate the total usage first, and correctly derives 230 liters. The inference cost is higher, but the logic is sound. Beyond simple math, we see a major shift in tool use. In physics tasks, the base model relies on memorized text formulas which are prone to error. The trained model recognizes the calculation risk and automatically generates Python code to verify its own derivation. We also solved the lazy list problem in logic puzzles, where the base model simply guesses the answer. The trained model explicitly outlines Scenario 1 and Scenario 2, deducing the correct box labels based on the negative constraints. Getting this pipeline stable on the provided hardware was as challenging as the modeling itself. We had to engineer the data for extreme conciseness. We enforced a hard 192 token limit on GRPO examples and a strict KV cache budget. In conclusion, we achieved 85% accuracy strictly within the contest's single-session constraints. While we had to aggressively prune the dataset to prevent out-of-memory errors on the TPU hardware, the results prove the curriculum works. With unconstrained compute to process the full context window, we estimate significant further gains. Thank you for your consideration.